everyone, welcome back to my channel. My name is Soumya. This is GCP Associate Cloud Engineer Practice Test Module 7 containing set of 20 questions. I have already uploaded 6 modules, each module containing set of 20 questions. Each of this module contains set of different questions. So I recommend you to go through all those modules so that it will be helpful to you when you take the actual exam. So let's get started with today's video. First question. You are the lead architect in your organization's project to migrate on premises deployments to Google Kubernetes Engine. You want to keep cost under control. What is the best way to do that? Option A. Configure autopilot in GKE to monitor node utilization and eliminate idle nodes. Here, autopilot is designed to reduce the operational cost of managing clusters and optimize your clusters for production. So, this option is correct. Option B. Create a cluster with the required capacity. Make use of sustained use discount to stay within budget. If you opt for this option, it requires manually resizing the cluster every time a new workload is added. So, this option is not correct. Option C. Use horizontal pod autoscaler to scale individual nodes up and down. Here, horizontal pod autoscaler is for adjusting the Kubernetes parameters for performance and it is not for taking out any unnecessary resources. So, this option is not correct. Option D. Create a managed instance group using several compute engine instances and set the group to scale up and down depending on load. Managed instance group cannot be used to create a GKE cluster. So, this option is not correct. So, option A is correct for this question. Next question. You are the lead architect of an e-commerce project on GCP. Your finance team has asked you to give them an estimate of expected Google Cloud spending in the next quarter. How can you come up with an estimate as quickly as possible? Option A. Predict your next month's spend using a custom machine learning model. This option is not correct because it requires custom programming and it's not a quick solution. Option B. Calculate the number of hours of compute time required and then multiply by the VM per hour pricing. Even this option is not correct because other charges such as storage and data egress charges are not considered in this approach. Option C. Use the Google Cloud Pricing Calculator to find out the expected spending of all resources in the project. This option is correct because the Google Cloud Pricing Calculator is the right tool to estimate GCP costing. So option C is correct for this question. Option D. Use the Google Cloud Pricing Calculator to find out the expected spending of all resources in the project and then adjust for volume discounts. This option is not correct because volume discounts are automatically applied in the pricing calculator. Next question. You are a data engineer working at a steel company. The equipment used at the factory generates logs and they are stored in separate files. A batch job combines all the log files into single file at 2 am. You have written a Google Cloud data flow job to process that log file. How can you make sure the log file is processed only once per day in a cost effective manner? Option A. Use Google Cloud Data Proc instead to do the processing. This option is not correct because Dataproc is more suitable for existing Adobe or Spark jobs and it is an expensive approach. Option B. Assign someone to manually start the data flow job every morning. This option is not correct as manually triggering the pipeline is not an efficient approach. Option C. Use a Google App Engine cron service to trigger the cloud data flow job every day. Cloud data flow job can be triggered using a cron job hosted on the GCP infrastructure. So this option is correct. Option D. Process the data logs immediately by configuring the data flow job as a streaming job. The cloud data flow streaming job only supports cloud pub sub triggers. So this option is not correct. Next question. You are building a SaaS product to share the latest commodity prices in real time. Your API will be consumed by customers in the following ways. Stream data in real time, ANSI SQL queries on real-time stream and historical data, historical exports of batch data. Which is the most suitable solution for this use case? Option A. Cloud data flow, Cloud SQL, Cloud Spanner. Option A is not correct because using these services we cannot achieve the stated requirements. Option B. Cloud PubSub, Cloud Storage, BigQuery. This option is correct. Using PubSub, we can stream the data and using BigQuery, we can perform ANSI SQL queries. Using cloud storage, we can do the historical exports of batch data. So here PubSub is an asynchronous and scalable messaging service that decouples services producing messages from services processing those messages. So PubSub is used for streaming analytics and data integration pipelines to ingest and distribute data. Using BigQuery, you can analyze data. Cloud storage is a service for storing your objects in Google Cloud. So you can store objects in containers called buckets. All buckets are associated with a project and you can group your projects under an organization. So option B is correct. Option C, cloud data flow, BigQuery. Using these services, we cannot achieve the requirement which is stated in the question. Option D as well. So option B is the correct solution for this scenario. Next question. You are working for a logistic company that has a 20 TB database containing system transaction data that they need to migrate to GCP. Which database option is the most suitable for this migration? Option A, Cloud SQL. So option A is correct as Cloud SQL can store up to 30 TB of data. Option B, Cloud Big Table. Cloud Big Table is not transactionally consistent. So this option is not correct. Option C, Cloud Spanner. Option C is incorrect because Cloud Spanner is a petabyte scale solution and Cloud SQL can handle 30 terabyte of data. So option C is not correct. Option D, Cloud Data Store. Cloud Data Store is not transactionally consistent as well. So this option is not correct. So option A is correct for this question. Next question. You are building a multiplayer mobile game on Google Cloud. You have chosen to use a managed group of instances within Compute Engine for your servers. Your game requires that the user's IP address is preserved in order to function normally. Your app needs to be exposed to the internet using TCP protocol on port 389. Which load balancer type is most suitable for your game? Option A, external TCP network load balancer. This option is correct because an external TCP network load balancer can be used to expose the application to the internet while preserving the client's IP address. It can distribute the incoming TCP traffic to the instances in the managed instance group and maintain the source IP address information. So, option A is correct. Option B, TCP proxy load balancer. A TCP proxy load balancer is used for proxying TCP traffic at the application layer, which is layer 7, and it does not preserve the client's IP address. So option B is incorrect. Option C, SSL proxy load balancer. Here, SSL proxy load balancer is used for SSL TLS termination at the proxy layer, and it is not designed for preserving the client's IP address. Option D, internal TCP network load balancer. Here, internal TCP network load balancer is used for internal TCP traffic within a VPC network and does not expose the application to the internet. So this option is not correct. Option A is the correct solution for this question. Next question. You are building an online marketplace where people can sell used goods. You are planning to use a relational database for the app, but you are unsure about the expected size of the user base. Your database needs to scale with rising user growth with minimum configuration changes. Which database should you choose? Option A, Cloud SQL. Even though Cloud SQL is a reliable and scalable relational database service, it may require manual configuration changes and has limitations in terms of global scalability and distributed architecture. And it may not provide the same level of automatic scaling and global consistency as Cloud Spanner. So, option A is not correct. Option B, Firestore. Firestore provides flexibility and scalability for document based data models, but may not provide the same level of relational querying and transactional consistency as Cloud Spanner. Option C, Cloud Spanner. Cloud Spanner is a globally distributed relational database service that is designed to handle scalable and consistent storage of relational data. It provides automatic scaling, strong consistency, and global availability, making it suitable for applications with unknown and growing user bases. So, option C is correct. Option D, Big Table. Here, Bigtable is a NoSQL wide column database that is optimized for massive scalability and high throughput. But it may not provide the same level of relational data modeling and querying capabilities as Cloud Spanner. So, option D is incorrect. Next question. You are building an internal portal on the Google Cloud platform on a custom VPC for your company. Your security team has mandated that the VMs cannot have access to the internet and they can only have private IP addresses. Your app needs to have access to files hosted on Google Cloud Storage within your project. How can you enable this access without breaching the security requirements? Option A. Enable private service access on the cloud storage bucket. Enabling the private service access on the cloud storage bucket alone does not address the restriction on VM instances connecting to the internet or using the external IP addresses. So, this option is incorrect. Option B. Create a VPC service control perimeter and add storage.google-apis.com to the list of restricted services and add your project to the list of protected projects. Here, adding storage.google-apis.com to the list of restricted services in a VPC service controls perimeter and configuring protected projects does not specifically enable internal access to cloud storage within the custom VPC. So, this option is incorrect. Option C. Enable private Google access on the subnet within the custom VPC. This option is correct because enabling private Google access on the subnet within the custom VPC allows VM instances in the VPC to access Google APIs and services such as cloud storage using internal IP addresses. So, this ensures that the application running on Compute Engine VM instances can access the file hosted in the cloud storage bucket without requiring external internet connectivity. So, option C is correct. Option D. Route the traffic to the dedicated IP address of the cloud storage bucket by deploying a Cloud NAT instance. This option is incorrect because deploying a Cloud NAT instance and routing traffic to the dedicated IP address of the cloud storage bucket assumes external internet connectivity, which is not allowed in this scenario. Next question. You are working at a financial services company that operates in the United States. According to data security policies, your company cannot store or process any data outside the US region. You have several development teams that use Google Cloud to work with the data. How can you restrict your teams from creating Google Cloud resources outside the US region? Option A. Create a folder that contains all dev projects. Limit resources in US locations using an organization policy. This option is correct because creating a folder to contain all the dev projects allows you to organize and manage them effectively. By creating an organization policy, you can enforce restrictions on resource creation in specific locations. In this case, it's United States. This ensures that each dev team can only create cloud resources in the US. Option B. Create an organization that contains all the dev projects. Limit the resources in US regions using an identity and access management policy. Here, creating an organization alone does not provide the granularity required to restrict resource creation in specific locations. IAM policies primarily control access to resources, not resource location. So, this option is not correct. Option C. Restrict the resource locations in the US using an identity and access management policy. Apply the policy to all dev projects. Creating an IAM policy to restrict resource locations in the US and applying it to all dev projects does not provide centralized management and control. It requires applying the policy individually to each project, which can be cumbersome and prone to inconsistencies. So, this option is not correct. Option D, restrict the resource locations in all dev projects using an identity and access management policy. Apply the policy to all dev roles. Again, creating an IAM policy to restrict resource location in each dev project and applying it to all dev roles also lacks centralized management and control. It requires applying the policy to each role in each project separately. So this option is not correct. So option A is the best solution for this scenario. Next question. You have built a two-tier application on Google Cloud with an application tier and one database tier. You created two subnets, subnet A and subnet B, in the default VPC, where the application tier runs in subnet A and the database tier runs in subnet B. How can you configure a firewall rule so that only the application servers can communicate with the database service? Option A, create two service accounts, namely SA app and SADB. Associate the service account SA app with the application tier servers and the service account SADB with the database tier servers. Allow network traffic from source service account SA app to target service account SADB using an ingress firewall rule. This option is correct because here it uses service accounts to control access between the application servers and the database servers. So, by associating the SA app service account with the application servers and the SADB service account with the database servers, you can ensure that only traffic originating from the application servers, that is from the source service accounts SA app, is allowed to reach the database servers. Here the target service account is SADB. The ingress firewall rule is then created to specifically allow network traffic between these two service accounts. So this option is correct. Option B, add tag app server to the application servers and DB server tag to the database servers. Allow network traffic from the source network tag app server to target network tag DB server using an egress firewall rule. This option is incorrect because network tags are not the appropriate mechanism for controlling access between different components within a VPC. Network tags are generally used for targeting resources for specific configurations or actions, but they do not provide the necessary granularity for controlling traffic between specific servers. Option C, create a service account SA app and a network tag DB server. Associate the service account SA app with the application servers and the network tag DB server with the database servers. Allow network traffic from source VPC IP addresses and target the subnet A IP addresses using an ingress firewall rule. Option C is incorrect because associating a service account with a network tag is not the correct approach for controlling traffic between different subnets. Additionally, allowing network traffic from all VPC IP addresses to subnet A IP addresses will not limit the traffic to the application servers. Option D, create a network tag, app server and service account SADB. Add the tag to the application servers and associate the service account with the database servers. Allow network traffic from source network tag app server to target service account SADB using an egress firewall rule. This option is incorrect because using a network tag for the application servers and a service account for the database servers does not provide the desired access control between the two components. Additionally, creating an egress firewall rule to allow traffic from the application servers to the service account does not restrict the traffic to the specific database servers. So this option is incorrect. Next question, you are building a very critical application for the defense forces, and one of the requirements is to have a centralized collection of all admin activity and VM system logs within your project. You need to collect these logs from both VMs and services. What should you do? Option A, rely on default functionality of Stackdriver to automatically collect all admin and VM system logs. Option A is incorrect because the VM logs are not collected by Stackdriver by default. Option B, Stackdriver automatically collects admin activity logs for most services. Install the Stackdriver logging agent on each instance to collect system logs. This option is correct because you can view all activity and VM system logs in Stackdriver if the Stackdriver logging agent is configured on the VM. It streams logs from common third-party application and system software to logging. You can configure the agent to stream additional logs. So option B is correct. Option C, deploy a custom compute instance running syslogd. Configure your GCP project and VMs to forward all logs to it. There is no need to launch a custom syslogd compute instance as Stackdriver is a managed service built for the same purpose. So this option is not correct. Option D, install the Stackdriver logging agent on a single compute instance. Let it collect all audit and access logs for your environment. Option D is not correct because all compute engine instances that require logging need to have the Stackdriver logging agent installed. So option D is not correct. Option B is the correct solution for this scenario. Next question. You have several workloads running on Google Kubernetes engine. One of the workloads needs to have a consistent set of host names even after pod scaling and relaunches. Which feature of Kubernetes can help you accomplish this? Option A, stateful sets. This option is correct because stateful sets represent a set of pods with unique persistent identities and a stable host names that JKE maintains regardless of where they are scheduled. The state information and other resilient data for any given stateful set pod are maintained in persistent disk storage associated with the stateful set. So this option is correct. Option B, role based access control. Role based access control is used to manage access to users and service accounts, and it has nothing to do with assigning consistent host names to pod. So this option is not correct. Option C, container environment variable. Host names are not managed by the container environment variables. Option D, persistent volumes. Persistent volumes are used to provide persistent storage to pods and they do not provide consistent host name. So option D is incorrect. So option A is the correct solution for this question. Next question, you have a large user analytics data set on BigQuery which is being used by multiple users in different teams. Your tech team has asked you to prepare a report that shows how many queries each user ran in the last month. What should you do? Option A, create a Google Data Studio dashboard by connecting to BigQuery. Create a dimension for the users and a metric for the amount of queries per user. This option is not correct because the activity logs are available from Cloud Audit Logging. Option B, execute a query on the jobs table from the BigQuery interface to get the required information. This option is not correct because there is no jobs table in the information schema. Option C, list all jobs using BQ show and use BQLS to list job information and get the required information for each job. This option is not correct because it requires a lot of manual effort and it should only be done as a last resort. Option D, view cloud audit logs in audit logging and get the required information by creating a filter on the query operation. This option is correct because cloud audit logs maintains audit logs for admin activity, data access and system events. BigQuery logs are automatically sent to cloud audit logs. So in the filter, you can filter relevant BigQuery audit messages and you can express filters as part of the export. So this option is correct. So option D is the correct solution for this scenario. Next question, you have built a framework that allows app to write logs directly to BigQuery. All applications built in a company use this framework. Each application needs to have its own table Also, logs older than 60 days need to be removed to save storage costs. What are the Google recommended practices for it? Option A, configure the table expiration time to 60 days. This option is not correct because it will delete all tables after 60 days and we want to only delete data that is older than 60 days. Option B, use time partition tables and configure the partition expiration at 60 days. This option is the correct one because if the partition expiration is configured, the data older than the configured duration will be automatically deleted. For example, if you set the default expiration to 60 days, older data is automatically deleted after 1 week. Option C, BigQuery prunes application logs older than 60 days by default, so nothing needs to be done. This is not correct because there is no default behavior to prune logs after 60 days in the BigQuery. So this option is not correct. Option D, write a script that uses a BigQuery command line tool BQ to remove records older than 60 days. Even this option is not correct. There is no need to create a script as BigQuery already offers this feature. So this option is not correct. So option B is the correct solution for this question. Next question. Your web app is deployed on JKE. The app has a backend service and a front-end service, both deployed as Kubernetes deployments. How can you make sure that the communication between the front-end service and backend service is not affected if pods are moved or restarted? Option A, create a service that groups your pods in the backend service. Configure the front-end pods to communicate through that service. This option is correct because the Kubernetes service serves the purpose of providing a destination that can be used when the pods are moved or restarted. So option A is correct. Option B, create a DNS entry with a fixed IP address. Use it in the front-end service to reach the back-end service. This option is not correct because a DNS entry is created by service creation. Option C, assign static internal IP addresses to the backend service. Use it in the front-end service to reach the backend pods. This option is not correct because static internal IP address do not automatically change when pods are restarted. Option D, assign static external IP addresses to the backend service. Use it in the front-end service to reach the backend pods. Even this option is not correct because the static external IP address take traffic outside of the Google networks. So option A is correct for this question. Next question. You have a banking app that pushes transaction data from application servers VM to cloud pops up for consumption by authorized services. You are building a recommended service that needs to securely access this data. What is the Google recommended approach for it? Option A, grant the appropriate cloud pops up IAM rule to the VM service accounts. Option A is correct because the service account can only execute API methods that are allowed by both the access scope and the service account's specific IAM rules. So to properly push data to pops up, the VM service account need to have the appropriate roles. Option B, use VM access scopes to grant the appropriate cloud PubSub IAM rules. The VM service account should not have access to cloud PubSub. Since the VM service account needs access to PubSub, this option is not correct. Option C, generate an OAuth2 access token for accessing Cloud PubSub. Store an encrypted copy of it in cloud storage and let the VM access it through GSUtil. Option C is incorrect because it is not considered a good practice to generate and store OAuth2 access token as they usually have an expiry period. Option D, use a cloud function as a gateway to Cloud PubSub. Grant appropriate Cloud PubSub IAM rules to the cloud function service account. This option is incorrect because VMs can directly call PubSub. There is no need to build a cloud function for it. So option A is correct for this question. Next question. Your multiplayer online game is hosted on Compute Engine. The game is made up of several VM instances running in the same VPC. Only paths and ports authorized by you should be allowed for communication between instances. But you can't rely on static IP addresses as the app can auto scale. Which is the correct way to restrict communication? Option A, restrict traffic using separate VPCs. Option A is not correct because there is no need to create a separate VPC for it as firewall rules are built for this purpose. Option B, attach network tags to the compute instances and use firewall rules to control the traffic. Option B is correct because network tags attached to VMs can be used to create a filter To apply specific rules to specific VMs. An auto-scaling group attaches the network tags to all VMs in the group. So option B is correct. Option C, use Cloud DNS and only allow connections from authorized host names. Cloud DNS does not provide firewall capability, so this option is not correct. Option D, use service accounts and configure the web application to allow only particular service accounts to access. Option D is not correct because we need to restrict communication between VMs. Service accounts are used to manage communication between applications and GCP services. So option B is correct for this question. Next question, you are uploading critical data files of your clients to cloud storage. As part of your internal policy, you need the files uploaded on cloud storage to be encrypted by customer supplied encryption keys. What should you do? Option A, use GSUtil to upload the files by supplying the encryption key in a .boto configuration file. A .boto file with an encryption key is used to supply custom encryption keys to cloud storage, but it will work for individual users. So every user should update their .boto with the same key. Also, while retrieving, you should use the same key for decryption. So option A is correct. Option B, use GSUtil to upload the files to that bucket by supplying the encryption key using gcloud config. This option is not correct because custom encryption keys are supplied with the .boto file and not through the gcloud. Option C, use GSUtil to upload the files, supply the encryption key using the hyphen encryption key flag. Again, this option is not correct because here hyphen encryption key flag is not designed to work with customer supplied encryption keys. Instead, this flag is used to specify the encryption key that cloud storage uses to encrypt data. Therefore, using the hyphen encryption key flag with a customer supplied key will not work as per the expectation. So option C is not correct. Option D, use GSUtil to create a bucket and supply the encryption key using the hyphen encryption key flag. Upload the files to that bucket using GSUtil. Here, the GSUtil command does not have an hyphen encryption key flag. So, this option is not correct. So, option A is correct for this question. Next question, you are leading a new project at your organization and you need to evaluate how your team's readiness for GCP. The main goal is to optimize cost on the cloud and you need to create a skills gap plan for the same. Your team has deployed a couple of GCP projects successfully to date. Which option makes the most sense? Option A, set up a budget for team training, set a deadline for the new GCP project. Here, option A is incorrect because allocating a budget and setting a deadline does not evaluate the team's GCP skills. Option B, set up a budget for team training, plan to get your team certified in GCP based on job role. Certificate is always a good way to ensure the team is proficient in using the GCP and that they will be able to create a cost optimal system. So, option B is correct. Option C, hire skilled external consultants to help with cost optimization. Set a deadline for the new GCP project. Since here the requirement is to evaluate the team's readiness to build a new project, there is no need to hire an external consultant to do this. So, option C is not correct. Option D, hire skilled external consultants, help with cost optimization, plan to get your team certified in GCP based on job role. Again, option D is similar to option C, which is not correct. So, option B is the correct solution for this question. Next question, you are migrating one of your internal on-premise application that uses the MySQL server to GCP. You need to make sure data center outage in any of the zones within a GCP region does not cause downtime for the application. What approach should you take? Option A, provide a Cloud SQL instance and enable high availability. This option is correct because Cloud SQL supports SQL Server and selecting high availability provides automatic failover within a region. So option A is correct. Option B, provision a Cloud Spanner instance with a regional instance configuration. This option is not correct because migrating Microsoft SQL to Cloud Spanner requires some migration effort which is not feasible for this requirement. Option C, set up SQL Server on Compute Engine, use always on availability group using Windows failover clustering, place nodes in different subnets. Option C is incorrect because Cloud SQL provides a high availability mode for failover protection. So this option is not correct. Option D, use Windows failover clustering to set up SQL Server always on availability groups, place nodes in different zones. Here, Cloud SQL also provides a high availability mode for failover protection, not always on the availability groups. So this option is not correct. So option A is correct for this question. That's it for today's video. I hope you found this video helpful. If you are new to my channel, please like and subscribe to my channel and stay up to date with the latest content on this channel. I'll be uploading content specific to cloud and DevOps. Thank you all for watching. See you in the next video.